Okay, we look at this question now and straight away think, this could be Finance Solver. So let's go ahead and dive in and grab some numbers. I can see 30 years here. I can see a deposit of 1,000. A deposit, that's money going away from me, so I'm thinking that's a negative. I can see, seems to be at the end of every month, so the deposit seems to be every month. Okay, so that looks to be a monthly payment, and the interest rate is 6.5%, but that's compounded monthly as well. Alright, so now let's tag those. When we switch straight away now to a Finance Solver, and we can put all these pieces in the right place, I'm going to go to a calculator, menu, Finance Solver. Now I'm going to go straight for the interest rate. Here's the interest rate. That's pretty clear at 6.5. But straight away I'm going to go to CPY. Alright, so interest rate is tagged with CPY. How many compounding periods per year? And it clearly says 12, right? Now if it was a one-off investment, then we'd usually match the PPY to the CPY. But this is clearly not a one-off investment. It says we're depositing 1,000 British pounds at the end of every month. So that's payment of £1,000. So that's money going away, negative 1,000. Okay, and that is every month, and that's every month for 30 years. This N is the number of payments, so that's 30 times 12 is 360. Okay. Now the present value is 0 because I'm not putting any money in. I don't have anything to start with. It's a payment regularly of 1,000. And look, the PPY here actually matches the payment here, and we're making 12 payments per year. And that is it. We find the final value. Part A saying to find the future value, the final value, giving your answer to the nearest pound. And there we go. So the answer for part A, you can see that clearly, is 1106,178. So we just write that down. Oh, let's get a pen on. 1106,178. So that's over in the millions. And it's always handy to write down your working out here. Now your working out is just writing straight down from the calculator the things that you've typed in. Alright, now the mark scheme says there's 3 marks available here. Now imagine you just copied this answer down wrong. You would get 0 marks out of 3 even though you've got the right idea. So always jot down the numbers that you used. I'll just take my time to do it here. And future value is what we're solving for. PPY is 12 and CPY was 12. There you go. So you put that down, you'll get 2 marks for method, and you get a mark for the answer. Sometimes 1 mark for the method, and sometimes 2 marks for the answer. So it's well worth putting the working out down. Alright then, part B. Part B is a strange one. It says, after the 30-year period, Charles will start receiving regular monthly payments of 15. Okay, so 1,500 times the number of months. That's how much this guy Charles is going to receive. I'm going to calculate the number of years it will take Charles's monthly retirement payments. So we're interested in this amount here to match the total amount originally invested. That's a bit of a weird one, isn't it? I've just noticed that's a 1,000 here, right? I made a little mistake there. It was 1,000 per month. Well, look, if I pay 1,000 per month here, and I paid 1,000 per month for 360 months, then clearly I've paid in 360,000 GB pounds. Now that's the power, isn't it, of investing for a long time? Because can you see that even though Charles has invested literally 360,000, he's actually got back over 1 million. So nearly 3 times the amount he invested he's getting back. And that's 2 things. One, the interest rate is pretty good, 6.5%. The second thing is it's invested long term for 30 years. Alright, so all those little pieces of interest add up. So anyway, we want to know how to put 360,000 in here and basically solve for m. So 15,000, sorry, my bad, 1,500, 1,500 times by m to give 360,000. Again, you can end solve, or I can do a little division. 360,000 divided by 1,500. We go to our calculator. No need to mess around. Get rid of that. Make this big. So 360,000 divided by 1,500. Boom, that's 240. Now remember, that was 240 months. Always good to write down the actual units for your answer.